Hello and welcome to this video tutorial on how to do jump prediction in Unreal Engine. This is going to be a tutorial that is just the bare bones of the jump prediction. It's in no way a production tutorial. It is just going to give you like the baby steps, like the basics, the first stair to go up and create a real jump prediction, because it is a topic very complex that has many corners that are not going to be covered in this tutorial, but it's a good starter, I think. So this is gonna be the end result. You jump and you can see it predicts where are you going to land. It also accommodates the animation depending on the duration in air of the jump to match with the animation. So pretty basic, but as I mentioned, it does not cover all the aspects that you will have to take into account in a proper game. Like for instance, if you jump against a wall, it does not handle that. Or if you just go off the wall, this is what is gonna happen. So no animation, just a single pose happening. But yeah, in a sense, it's just jumping and predicting. Okay, so I have created this empty project. Yeah, from the templates in the Epic Games Launcher. Doesn't have any of the features I just showed you. It's just a simple character, the base one, no changes. So first thing that we are going to do is create a new class for the character movement component, which is gonna be a character movement component. That is the parent class. I just called the project GP, so I named it GP character movement component. Okay, here is the class. Okay, so here's what is gonna happen. I don't remember exactly where is that, but Unreal already has that prediction built in. So now what I'm going to do is just edit this guy, and I remember there was something here called like predict path. Oh, here, projectile path advanced. And then I'm going to go to the definition. We'll just delete this one and go to the definition, and yeah, this one. So we are just going to copy paste this. We are going to copy paste this in some method here that we are going to call I don't know, predict jump path, and this returns a boolean public bool predictable path. Actually, let's call it protected, and these will need this guy, and okay. So let's read through the code and see what we need and what we don't need, and just modify it just for our needs. So yeah, it is using this as an output for the result, and we are going to keep the result in the in the cache, or I don't know, we are just going to cache the result. So afterwards we can read it in blueprints. So we are going to create a member variable like this. That is gonna be just blueprint read only category movement, because we are in the movement code. Okay, here it is resetting the result. Okay, here is just getting the world from a context object. We don't need that. We just need get world. Well, simulation frequency, simply zero, gravity. We don't want this to be fed by the predict parameters, which are coming from here. Oh, we also don't need this world context object. Can get rid of that one. But in the movement component itself, we have this method, so we can get rid of this one, this line of code. Yeah, this is in the character movement component, and yeah, it just takes into account the gravity scale and yeah, whatever. Projectile radius, we don't need this really, because we are now handling the movement with the capsule of the character, so no spheres. This is for the query stats. We're going to call it predict jump pad as the function. Object query params, trace with object type, trace path, trace with collision. I don't think we need all of this. Maybe we just need this, yeah, and this. So the actors to ignore is gonna be the character owner. Yes, because we don't want to do the traces and hit ourselves, right? So we hit, we add here the character owner. And why is complaining? I don't know. Much the argument list. Ignore actors, character owner. I think it's because we don't have a character. Yeah. Let's see afterwards if it compiles. I don't know why it's marked red. Much the argument. Add ignore actors. Oh, because it is expecting an array or what? What is this? What is this doing? Yeah, it's an array. There is no add ignore actor. Yes, let's replace it with this one. Actor. Yeah, like that. Collision channel. We don't need that. We just need to use the get capsule. No. Get character owner. Get capsule component because it's the root object. What was the name of this one? Get collision object type. That is a channel that we are going to trace through. Capsule component, because it's marked because we don't have the class. Oops. Let's add this in here. Object types to query. So we are adding here the channel where the capsule is using to be our trace channel. Like we are going to trace against that channel. What is this? Launch process start, trace in, current time, at point, yeah, this is good. Hit result, object trace hit channel. I think we don't need this one. just the channel, because we are using just the trace by channel and not by object type. So let's get rid of that. And here is doing the iteration with a max simulation time. All velocity, whatever. Object hit, we're not using that. Trace. Oh, okay, here is where the magic happens. Well, not the magic, just the tracing. The magic is here. They are integrating the path with the Berland method, but as I said, we don't need to get into it because it's already implemented. So as we are tracing with the channel, we don't need an if. We already know we're doing a trace with channel. So we are going to trace with the heat, channel heat that we're just done here. Trace start, trace end, identity. No. Here we are going to use the character owner get actor quaternion. Quaternion. Trace channel, make a sphere. Okay, this needs to change to be a make capsule, and the capsule needs float capsule radius, capsule height, and we get that from character owner. Get capsule component, get scaled capsule size. I think it's this one. Yeah, it needs the radius, so the ones that we just created. Let's move this out of the while loop, like here. So we can use these parameters instead for creating our shape. There we go. Okay, what else it is doing? Object hit, not used anymore. I think we can just get rid of this part. Just do this. Hit result. Okay, if it hit, we don't need to ask to this guy, but channel hit. Hit time delta, that is probably okay. At point, blah blah blah, at point. And here is for draw debug. Persistent, yeah, whatever, projectile radius or radius. Okay, this needs to go away. Draw the path. So instead of draw the book sphere, we use draw the book capsule. Yes. Path location, and what else does it need? Radius. What is this? Oh my god. Half height, center, half height, and radius. Okay, so capsule half height and capsule radius, and we'll need this parameter green. Oh, rotation. This is gonna be the character. Actually, I think we can cache this. Instead of doing this call all the time, we can just create here a concept quad character rotation to be this, and then we can put it here and put it here. Okay, I think that is good. This is good, this is good, yeah. Draw the path with green, and this is going to draw it with red if you hit something, and it's just gonna increase the size by 1 unit, so we will do the same but for the height and the radius. And path point, what is this? Oh god, let me see. Predict path result. get result.location. Okay, that's it. So for the method itself, which is the core, is this actually the core of the method, we are done. As you see, it was just a copy paste from something that was already in Unreal. Okay, so now we need a way to call this, right? So to do that, we can go to the parent class of this object and search for something that must be called jump. Do jump, I think is this one. Yeah. Here is where the jump is performed. So we can just override that method. Override. So this is the overridden do jump method. We are going to just check what is the result in the parent. Do jump. We replay moves. Has no member. Do pawn movement. Oh god. Character movement component. Yeah. Has a do jump. Yeah. I don't know. This is marking it as an error, but it's not. And then we return the B result. But in between this, we are going to check if this succeeds. And if so, then we are going to call our method, which requires these parameters. So we are going to fill them with the information that we need to fit to the query. So what do we have in here? We need, of course, the start location. Start location is equal to character owner get actor location. What else do we need? Launch velocity, of course. We need the velocity. With collision, practice now, we don't use this. Maximum simulation time, we do need that one. And this is at your discretion, you know, so I think the max simulation time for the jump prediction must be no more than 5 seconds maybe. But you know, if you're just jumping from a cliff, it could take way more, but I guess if you jump from a cliff, your character is gonna be die, so. Trace with channel, we don't need that, no. No. Sim frequency, yes, this one is important. Predict parameters, sim frequency, I think 30 frames per second is gonna be okay, even though if your game could be running at 60 frames or 120 frames per second, I think 30 frames per second is gonna be enough for, yeah, accuracy in those cases. Draw debug time. Am I using that? Let's see. Resistance, lifetime, for duration. Yeah. Okay, let's just fit that here. Predict parameters. Draw debug time. I think 3 seconds is a good choice. What else? Trace complex, we don't use that, blah, blah, blah. Yeah, should be enough. And then we call, how is it called? Predict jump path with the predict params and predict result, which is the member variable that we created. Did we create it? Predict result. Predict parameters. Path result. This member variable is of the path result type. Okay, we just plug it in here, and let's compile. I will put the compile window here so you can see it. And should compile fine. Let's see. One failed because, just because. Unable to build while live coding. Oh, yes, I have to close the editor. No. Let's build again. You know what? I will pause the video while this compiles, so you don't get bored. Okay, so we have a problem here, which is that I am, yeah, what is it called? Shadowing the name of the variable that I already created here. So let's name it differently. Or you know what? No, or yes, no, yeah. Let's call it differently. Predict result. I don't know. Jump. Predict result. Super specific, but could be more generic. Please compile, please, and succeed. Okay, let's see. In theory, it should work, but let's see. Is this open and play and it's not doing anything. Incredible. Let's see why. Just put up right one here. Jump. Oh, of course, it's not working. It's because I need to use this class as the one that is going to be used by the character, and I have not done that. So I will edit this class, and I think I can do that. I remember in Unreal Engine 4 you had to do something in the constructor, but I think now you can just select the class here. Let's see. Yeah, okay, and play, and that didn't work, seems to. Okay, it's been called. The jump result, predict jump path. La 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 la. It should draw the bug. Whatever. Debug type. None. Huh. Did I put? Oh wait. Okay. So I didn't set this property. Predict params. Draw debug type. What is the type? Draw trace for duration. For duration. There we go. Yeah, excellent. Still not working. Should draw all the path. Okay, so the problem was that I was setting the incorrect simulation frequency. So instead of doing this, I should have just plugged the 30. So 30 times per second, let's say. And the sub-step delta time was already being simulated here. So that was causing the issue. But now with the 30 here, it is working. Kinda. And why, you wonder? well, it's kind of working, but I'm new because I have been doing this many years before, and I know that at some point it does not match perfectly, like this case, exactly. So if we do slow-mo 0.1, you will see the difference when landing. And I'm pressing the down key, so it's completely off. But if I just hit jump and leave the keyboard, it's gonna match pretty much precisely, yeah. And that is for one reason. This method has a trade-off, and is that it assumes that the launch velocity of the character is not gonna change during the path while you are in air, but in the character movement component we have something called air control. Exactly. So that means that if you are in air and you are pressing your mouse or your gamepad, I mean your keyboard or your gamepad, you are going to be able to move the character in air. And as I said, this is a very, very basic implementation. So in order to not have that problem in the prediction, we just need to set this to 0. And with that, it's just gonna work. But I'm pretty sure in a real world game, you will need this, or maybe not, but who knows. But if you need this, you will need to handle the, I don't know, check if you are moving the stick or whatever and detect that event and recalculate, you know, like recalculate, and yeah, handle that case. But now it just matched perfectly. Slow-mo and show collision, and if I jump, I keep pressing in different directions, no matter what, I cannot change the velocity character started. So it's gonna land in the location I expect it to land. So if you are okay with the tutorial at this point, then you are pretty much done, because that's it, right? Predicting where the character is gonna land, and is doing that already. So the red one is going to be the hit location, but as I mentioned, it does not handle the case where you jump against a wall and fall down, right? So you will need to do a lot of stuff for this to work properly. But baby steps, here it is, jumping and then predicting the land. Okay, now let's move to the second part of the tutorial, which is synchronizing the animation with time in air and the end point of the jump. So for that, we are going to need to modify the animation blueprint, which is where is it? It is here. And for that, I'm gonna replace the jump animation with one that has all the jumps in one single animation. This animation I got from I don't know, one of the free marketplace releases. And as you can see, it's just one animation that has all the parts of the jump in it, so it's not divided into jump, in air, and land and per-land. No, it's just all the animations. So jump, in air, and land. So we just need to synchronize the duration of this animation, which is I don't know what is the seconds. It's about 43.43 seconds. So we just need to scale the time, or sync the time of this animation to whatever is the arc described by the jump. So how we do that? We just come here, locomotion, wall run, what is this? Oh, this has changed a lot. Idle, where is the jump? Main states, jump. And yeah, as I said, this one is just dividing all the animations into the jump animation into multiple ones. But as we are not going to use this part, let's just, what is this land? It's a land animation. Okay, that should be fine. The state, which I'm gonna call jump, and this is going to be it's going to be from here, and locomotion to jump, and I don't remember what is the is falling. Let's use just is falling, which is not totally true because you can fall just out of a ledge without jumping, but should be fine at least for this tutorial. This is the condition to go to jump, so if is falling is true, then go there, and if it's not falling, then just go to land. Oops. Not boolean. And for the animation we are going to use the this one. And this is the trick. We are going to use this convert to single frame animation. That way we can just fit whatever time we need, and the animation is gonna just jump to that frame. And for that we are going to expose this as a variable, and we are going to call it jump, explicit time. And in here we need to access the character movement component that we just created to be able to access this parameter, this property I mean. So how we do that? We need to cast here to actor character movement, and cast this one to cast to character movement component. We can plug this one here, and we can just, of course we can set these to JP character movement component, but it's being used everywhere, so I don't want to mess with that. You can do that in your home. Set JP, okay, and promote this to variable as JP character movement component. Perfect. And here we are going to add a pin, and from here we just need to get jump, what was the name? Jump predict result. And this has the time somewhere. Jump predict result last trace, so it must be here. Jump predict destination time. So this is the time it takes for the starting location to the end location. So the air time, we will call it. So this is just a simple rule of three, right? In where we have the animation time, which is 0. We don't need that last frame, 0.44. So 0.44 is gonna be, okay, so how is this rule of 3 going to work? Let's see. 0.44 is the animation time. Let's just do animation time. Animation time is 2 jump time. Actually it should be this way. Jump time is 2 animation time. So we will need to track what is the time the animation, at what time the animation started, so we can know how much time has passed since we started to jump. So we will need to create a variable called, I don't know, jump elapsed time. So that's gonna be the rule of 3, right? It is gonna be our x, and that is the variable, that the value of x is what we are going to fit to the explicit time variable that we created here. So x is equal, you know, this is just gonna be jump elapsed time by animation time divided all these in between parentheses, because you know, jump time, right? So this is our formula to do that, but we just need what is the elapsed time. Okay, so how we do that? Yeah, let's create a property here, which is just property. Yeah, no, not a property. Just a float, and we are going to call it elapsed time. No, we need a timestamp, and then from the timestamp we can get what is the time that has passed. So we don't use a tick to increase that variable. So jump timestamp. And let's create here a if function, blueprint callable, and make it blueprint pure. And this is gonna give us a jump elapsed time. Jump elapsed time const. So how is this gonna work? So we need this to be set when you jump. So here, if we were able to jump, then let's put it here. This is gonna be get world, get time seconds. So the timestamp when we started to jump, and get jump elapsed time is gonna be this same thing but inverted. So const float elapsed time equals to, so is the time minus the timestamp, so that is elapsed time, and we just return this elapsed time. Okay, and we need to save everything here and close and compile again back to our animation blueprint. So the formula was jump elapsed time, which we get from this guy, get jump elapsed time. This is a method that we just created, multiply it by animation time, which okay, this is another drawback from this method. So as this is just a prototype way of doing this, we just need to hard code what is the animation time. But in a real world environment, you will probably, I just write because I cannot write and speak animation time. In a real world environment, you are not going to use an anime instance as the parent class, and you will probably have a reference to this animation, and from C++ you can get the animation time in execution time. But I don't know if you can do that in blueprints. I'm not sure. I'm not very good at blueprints, but in C++ for sure you can do it, but that is gonna take too much time, so I don't want to do that. And let's just hard code the animation time, which I don't remember was how much. 0. I don't want these extra last frames, because as you see it's standing. I just want animation to end at this frame, so 0.44. So let's fit that here, 0.44 seconds. And so the formula was this. Oh, come on. Multiply it by animation time divided by the jump predict time. And if it's falling, whatever, then we just set this jump explicit time. But this thing is on the tick of the animation, so we can have a problem here, because at some point this trace is gonna be 0, right? So, and this is gonna be a division by 0, and we don't want divisions by 0. So I will be just a nasty blueprint programmer, filthy blueprint programmer, and do this horrible fix. And if this is less than or equal to 0, well, it can be less, but yeah, anyways. If it is less than equal, or if it's 0, this is not going to be executed. And I hate this spaghetti code that blueprints gives you. But in the other side, it's just good for prototyping. That should be enough. So we get the time, fit it here, and then we fit it here, and then here we are jumping to this state if it's falling. If it's not falling, we'll do this animation, which I'm not sure it's gonna be look okay. So let's try that. And no, it's not working for some reason. Why is it not working? Okay, so the stupid mistake was that oh, what happened? That yeah, this conditional was like this. So if the time duration is less than equal 0, then do this. And of course, it won't work. So it will be like this, better. And let's check. Okay, now it's working. Bloop. Perfect. So, bit of cleanup, compile save, and yeah, as you can see, it is synchronizing the animation, the jump animation with the time you are in air. Whoop, yes, whoop, yes, whoop, 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 and that's it. That's this tutorial. Remember, this is just the first step on a very complex system that you have to handle a lot of cases, like this one. So yeah, I hope it helps. People has been asking around in my YouTube channel for a lot about this channel, and I just simply don't have the time to do as many tutorials. And as you can see, I'm not a experienced YouTuber or whatever, but good to help people when you have some time. Yeah, hope it helps people, and cheers.